In this video, I'm going to do a follow-up on my other video, factoring quadratic trinomials. Now, we did the slide and divide method before. This method is going to be by grouping. So we'll start with one of the examples I had done before, k squared minus 13k plus 40. And we can set this up the same way, so that a is 1, b is negative 13, and c is 40. So we established before that a times c was 40, b was negative 13, and so the numbers we were looking for were negative 8, and negative 5. I'm going to show you what to do with those in order to then factor by grouping. So we'll take k squared. And essentially what we're doing with these two factors is breaking apart the negative 13k. We will do so by using negative 8k minus 5k. Notice that negative 8k minus 5k is negative 13k. So we have not changed much in this question except to break apart your middle term. Now, to factor by grouping, it'd be a good idea to brush up on your factoring the GCF, because that's what we'll be doing, but in groups. So I'm going to pair these up. I will pair the first two terms together and the last two terms. Then we'll take out the GCF. In the example here for k squared minus 8k, you will take out the k. What you'd be left with is k minus 8. And for these two terms, you will take out negative 5, because that would be the GCF for these two terms, and you'd be left with k minus 8. Now notice that this entire expression is one term, and this entire expression is another term. They both have k minus 8 common to them, and so we'll take that out. And then what's left would be the k here and the minus 5. But keep in mind that we could have done that directly from here, where we have k minus 8, k minus 5, and then divided by a. And we would have achieved the exact same answer. So yes, the slide and divide method is easier, but just in case you're required to learn the factoring by grouping method, then this would be the way to complete that. However, you sometimes will need to know how to factor by grouping, because if you are given 4 terms that are not necessarily like terms that you can simplify, then it would be a good idea to practice this method.
Hey, if you haven't liked, shared, or subscribed yet, go do that now. Okay, bye.
Let's take 4x cubed minus 8x squared minus x plus 2. Now notice this is a polynomial with degree 3. So here would be a good place to factor by grouping because we have 4 terms. So we'll take these two together and then the last two together. The GCF for these two expressions would be 4x squared. What I'm left with is x minus 2. From here, I can take out a negative 1, leaving me with x minus 2. Generally, you want whatever is in parentheses here and here to be the same. If they're not, then maybe you'd have to work around it a little bit. So just taking out a positive 1 would have left you with a negative x and a positive 2. And so taking out a negative 1 for these two terms would have been the best option, so that we have x minus 2 in both parentheses. Now this is one term, and this is another. They both have x minus 2 in common, And remember, factoring out, or to factor, is really to take out what is in common and write it as a product, so that when you multiply, you get what you started with. So we're going to take out the x minus 2 that we have in common, and then what we're left with is 4x squared minus 1. Now, if your question says to factor completely, you have to make sure that there are no other methods that you can use and that it is in its simplest form. If you watch my difference between two squares video, you'd realize that this is actually a square minus another square. So how we can factor this completely is by writing our first factor, but also breaking up our difference between two squares as 2x plus 1 and 2x minus 1. And now this would be fully factored. Hopefully this helps.